In this video, I'm going to step through how to use the software for Lab 7. So Lab 7 is over building circuits, over Chapter 4 content. You can read through the chapter or view the videos, look at the PowerPoint, whatever tool you find best for learning. The lab is a simulation for building circuits, which were discussed in Chapter 4. So you're going to have a jar file. This will be hyperlinked. A jar file is a Java applet. You will download this, and it will execute as long as you have a valid Java runtime environment properly installed. Most computers do. However, if it does not execute, then you will need to download the Java runtime environment. Can be found here at java.oracle.com. But I believe most of you have probably have this installed. In the files section, you will have the applet itself, and then you have two other files linked. These are the instructions. In this link is the answer sheet that you will need to complete. But first, let's step through the instructions. To execute the jar file, you will double click, and here is our simulator. Let's start by just going to this drop-down box and clicking on Simple. And let me explain some of the circuits that you see here. So these are your inputs. Your inputs will be called switches in this drop-down. And the values can be switched on or off. Right now, both are in a default state. Then you have connectors connecting the input to an AND gate. Then you have another connector connecting the AND gate to a NOT gate, and finally a connector to the output. So if you want to click on Run, you will see that if input is 0 and 0, you are ANDing that value, and you get 0. And then you're going to NOT the 0, and you get 1, so 1's for output. You can click on these inputs and switch them. So if there's a 1 and a 0 for input, the output's still 1. And if both are 1, your output will be 0. And then click on Stop. When you're ready to build another circuit, click the Clear button. And let's take a look over here. Let's go ahead and build the circuit that you're going to find on page 104 of the textbook. So page 104 of the textbook has two AND gates and an OR gate. You will notice that there are 3 switches. These buttons are kind of active when you see an asterisk by it. It's just a toggle. Now, if you click on New, the software is trying to help you out to figure out what you need to do. So here I have Delete active, and we're going to click on the Delete gate. So I'll make sure I turn that off before I do anything. And so now I'm clicking on New, and looking at that diagram on page 104, we have 3 inputs. So I'm going to click 3 times, and you can line things up and move things around. And I now have my 3 inputs. Next, I have 2 AND gates. Okay, so click and create 2 AND gates, and then followed by an OR gate, and then my output. Okay, I'm going to click off New, and I prefer to use this Connect button to make my connectors. So you see the connectors are active. Click inside the initial control to the next. So A is going to this AND gate. Now if you take a look at the circuit, A will also be going to this AND gate. It doesn't look as pretty. Doesn't look as pretty as it does in the book. And then this one, this is C. C is going to this AND gate. So here we're getting A and B, and here we're getting A and C. Now if you'd like, you can click on Label. So when you click on a label, you can click on the item. I'm going to type an A and hit Enter, and now that's labeled as A. This is labeled as B, and this is labeled as C. So let me continue with my connectors and see Connect is now active. I'm going to connect. And so here is my circuit. We'll go ahead and run it. And if you take a look at the truth table on page 105, that truth table is for this circuit. When all inputs are 0, the outputs are 0. Let's use one of, when A and C are 1, the output should be 1. So let's go ahead and click on A, click on C, and you notice the output becomes 1. Notice that you get to determine all the intermediate values too. So that's that circuit. We'll clear. Finally, the last circuit in these directions tell you that really a truth table and the logic diagram are equivalent. So if your circuit is very, very complex, you may put the truth table in instead. So let's try that. So we're going to build a new circuit. And we need, looking over here, we need 3 inputs. And we need a truth table. Now, if you do what I did and just not think through what you're doing, what's going to happen here is when I clicked on truth table, I get a prompt for number of inputs. Now, the number of inputs is the number of bits, right? The number of bits that are coming in. And if you have 2 bits, you have 4 rows because you're going to, this bit can be 0 or 1. This is the base, 2, and this is the exponent. So I'm going to click on delete. And let's try that truth table again. Now, what you may have, if you don't see the prompt for how many rows, just select a different one and come back to truth table. Okay, I'm coming over here. I'm going to select a 3, and I'm going to hit tab. Now I'll click on my truth table. Yes, I've got 8 rows. And I need my output. Of course, taking a look at this truth table, it does not agree with the truth table that I see in the directions. So I'm done with the new. I don't want to delete anything, and I'm going to connect. Okay, so I've got everything connected. I'm going to turn that off, and then I'm going to select my truth table, make sure that it's red, and go to Edit Truth Table. The first 2 items are 1. And then it's going to have a 0. And so, yeah, this last column is representing the output, and the first 3 columns are representing the input. So this is really all built for you except for the output. Click OK. And there, finally we got the truth table updated. So if I have an input of 1, 0, 0, I should see an output over here of 1. Let's run it. Well, it looks like if I have an input of 0, 0, 0, I have an output of 1. And let's change this 0 to 1. And my output's still 1. Let's choose one that's 0. 1, 0, 1 should output 0. And sure enough, it did. Okay, and stop. So let's talk about then the answer sheet. Here is our answer sheet. This is what you will be completing. And you will be building 5 different circuits. The most complex one is circuit 3. So in circuit 1, for example, you're going to clear and you're going to build a circuit that has 2 switches and an XOR and an output, connect them, run them. After you build that circuit, let's say this is the circuit, it's not. But after you build that circuit, what I want you to do is get your Windows snipping tool. And if you have Windows, probably have the snipping tool. It's part of what Windows offers in their operating system now. Otherwise, somehow get a screenshot. So here is my snipping tool. I'm going to click on New, and I will select my circuit and copy. Control-C or Edit Copy. Okay, and then I'll come over here to Word. And if this were circuit 1, I would just paste it right in there. Okay. And move on to circuit 2. So I want you to try different configurations. I don't necessarily want the 0 input every time. In this one, I say press the run button, try all 4 combinations, record the results in a truth table, and take screenshots. You don't need to take screenshots for each combination. Post 1 screenshot. So post 1 screenshot, and that'll work out fine. And you will do the same thing for each one of these. Now this third circuit, this is labeled A0, A1, B0, B1. And I'm going to get a true or a 1 when the bits A0, A1 are exactly the same as the bits B0, B1. So if this were 1, 0 and this were 1, 0, that's a match. I should see a 1 here. If this were 1, 1 and this were 1, 0, not a match. So A1 needs to match B1. A0 needs to match B0. That, of course, is the requirements to say that these two are equivalent. I didn't give you the gate here. In addition, you don't see the connection here, but I do tell you in the reading. But see if you can figure out what the connection is for A0 and B1 here before you do it in the reading. Mystery gate, you need to figure out what gate. Well, try one or the other and test it, see if it works, and if it doesn't, then try the other one. You will complete this, paste all 4 circuits in here, and then go ahead and submit this. I hope you have fun doing this lab.